We're going to go ahead and evaluate this limit by using big little logic. Okay, so the idea here is we're substituting infinity, which is the same thing as a really, really big number. And when we do this, what we're going to see here is we're going to substitute in. We're going to say this is 9 plus the square root of something big squared minus 2 all over the square root of 36 times big squared plus 1. Now, the idea here is we're going to say certain things are keeping us from simplifying this function. And in the reality, as x approaches infinity, they don't matter. So the idea here is if I had big squared, if I had a number that was a trillion squared, and then we said minus 2, you wouldn't even see the minus 2 in the graph. This would be unimportant. So the square root of big squared is essentially the same thing as the square root of big squared minus 2. They're the same value. So by just literally eliminating the minus 2, it allows us to actually do the square root. Similarly, down here in the denominator, the plus 1 can be eliminated. Now, the 36, that has to stay because this, if we were to say a trillion squared times 36, you would see that multiple of 36. That would be visible on the graph. It's going to have an impact on our values. And now that we've done that, now we can finish simplifying here. We say the square root of big squared, that would be big, over. Now the denominator, the square root of 36 would be 6, and the square root of big squared would be big. And now we're able to probably take a step back and do the problem again. We're going to look at this and say, okay, on the graph, which of these things would be visible? In the numerator, and we always think of it numerator in complete separate thought than the denominator. So looking at the numerator, just looking at the values up here, we're going to say, of these, if I had a trillion and then we said plus 9, we wouldn't see the plus 9 in the graph. So we can eliminate it. We can say that's not important for evaluating our limit because we're not trying to find out what the value is. We're trying to find out what the value approaches. It will give us a good glimpse, a good look at it. And then down in the denominator, can I scratch out the 6? Well, no, because if big was a really, really big number, like a trillion or something, big, that wouldn't even be close, but just as an example, whatever a trillion would be. And then someone said times 6. Well, yeah, you would notice that because that would become 6 trillion. So that 6 can't go away. But now that we've eliminated the 9, now what we're looking at is big divided by 6 big. And these would simplify. A trillion divided by a trillion would result in 1. So that would leave us with a y value of 1/6. So you can see using big little logic, we're able to figure this out pretty quickly. Now, I'm going to go back and do this the quote unquote right way. We're going to go back and do it using a little bit of algebra. Okay, now using algebra, what we're going to say is if I need to eliminate all of my variables. I need to make it so my variables are all a number divided by x. If there's anything left, they have to be in the denominator. And what I'm going to know is whenever I have a variable inside of a square root, it's always half of that power is what I need to divide by. So x squared, well, half the power would be x to the first. So I need to divide my numerator by 1 over x. Well, whatever I do to my numerator, I need to do to the denominator as well. Now, I'm going to go ahead and distribute this 1 over x through, giving me the limit as x approaches infinity of 9 over x plus the square root of x squared minus 2 over x all over the square root of 36x squared plus 1 over x. Now, to be able to eliminate my x's that are trapped inside my square roots, I'm going to need to move this x into the square root. And we're going to do that actually pretty simply. We're literally going to just do a rewrite. We're going to square and square root both of them. Because if we square and square root, it doesn't really change the number. It's just changing how it looks. And we're going to recall that when we learned how to do square roots, if we had something like maybe like the square root of 4/9, we said, well, that would be equal to the square root of 4 divided by the square root of 9, which would then become 2 over 3, right? So what we're doing is we're going backwards. We're saying, look, I'm going to square and square root my numbers, which would put us back to here. And then I'm going to take them from when they're both under radicals, and I'm going to put them back under one radical. Okay, so I have already done the square and the square rooting, so now I'm going to do a rewrite. I'm going to go ahead and put this back. So we're going to say it's still the limit as x approaches infinity of 9 over x plus the square root of x squared minus 2 over x, all under the radical. Let me make sure that's really clear. Over the radical of 36x squared plus 1 over x squared. I apologize. This should have been x squared because it was squared, right? So this should both be x squared. Okay. Now we're going to even go a little bit further with this desimplification. We're going to go ahead and rewrite the x squared minus 2, each of them over x squared. So if you think about how we add fractions, we're going backwards. We're adding subtracting fractions by getting common denominators, then we put them together. Well, they were already together, and now we're going to pull them apart. So you can see I now have my x squared under I have x squared divided by x squared and 2 divided by x squared. Same thing for the denominator. We're going to say this is all under the square root. So this is 36x squared divided by x squared plus 1 over x squared. Okay, now the neat thing at this point, here's where the big little logic kicks back in. We're going to say we're going to substitute infinity into everywhere we have an x. And, oh, actually, let's do one more step. We'll make this a little more clear. You could do it here, but let's just do a simplifying. X squared divided by x squared. We know that makes 1, right? And so x squared divided by x squared, so we know that makes 1. So let's do one more little rewrite. So this is going to result in the limit as x approaches infinity of 9 over x plus the square root of 1 minus 2 over x squared, all over the square root of 36 plus 1 over x squared. Okay, now that we've done that simplification, now let's do that next step. Let's substitute this infinity into everywhere we have an x. And we can't write infinity though, so we're going to write big in its place. This is where the big little logic comes in. So this is 9 divided by big. Let's go away, keyboard. There we go. Plus the square root of 1 minus 2 over big squared, all over the square root of 36 plus 1 over big squared. Now, what's the big idea? Very punny. Okay, well, what is 9 divided by something big? Well, if I have 9 pieces of bread divided amongst everybody on Earth, everybody's getting 0. So essentially, this becomes 0. Plus the square root of 1 minus, now same thing here. We have 2 divided by big squared. What is 2 pieces of bread divided? You already know the answer. That's basically 0. So this would be 0. And then, last but not least, over here, down here in the denominator, this is going to be 36 plus, what's 1 divided by big squared? Well, once again, that's going to be 0. So what will this result in? When we clean this up and get rid of all of our zeros, we're going to be left with the square root of 1 over the square root of 36, which simplifies to be 1 over 6. So you can see we got the same answer we got the first time. Oops, which I erased. But the same answer we got the first time using the big little logic straight away. This way is a little more algebraically correct, where we're actually showing the x's, dividing through and using big little logic to get the answer of 1/6. So what can we say? We know that this limit, the y value that this limit approaches as x approaches infinity, is 1/6.